To finish off with, let's just do some practice with the quantum numbers. All right, so our first question here, we're going to look at an n value of 3. And so we're going to assess at n equals 3, what values of L can exist, what values of m sub L can exist, and within that, how many total orbitals can we have with an n value of 3? Let's take a look. All right, so we have n equals 3. So our possible L values are going to be 0 to n minus 1, which translates to 0, 1, and 2. Okay? All right, so for each L value, we'll have some m sub L values. So for L value of 0, now remember m sub L is negative L to positive L. Okay? So if an L value is 0, the only m sub L value we can have is also 0. Okay? All right, now for an L value of 1, if I can go from negative L to positive L, that means I can go from negative 1 to 0 to positive 1. All right? And our last L value of 2, we can go from negative 2 to negative 1 to 0 to positive 1 to positive 2. Okay, so now let's assess the number of orbitals. All right, so if we only have an m sub L value of 0, that's 1 orbital. I have an m sub L value of minus 1, 0, and plus 1. That's a total of 3. And then for my L equals 2, I have negative 2, negative 1, 0, plus 1, and plus 2 for a total of 5, which gives us 9 orbitals. Okay, with, not L, 9 orbitals with an n equals 3. So I can potentially have 9 different orbitals that all have an n value that equals 3. All right, now we're going to take a look at some various different n and L combinations, and we're going to figure out the name of the orbital. So is it a 1s? Is it a 4f? All right, we're going to figure out the name of the orbital. We're going to get the m sub L values and the total number of orbitals allowed with the particular n and L combination. Okay, so we're going to have a given n value, a given L value. Okay, then we're going to give the name the sublevel name. We're going to define our m sub L values, and then we'll figure out the number of orbitals. All right, so A had an n of 3 and an L of 2. Okay, so if the n is 3, our sublevel name is going to be a 3 something. So for an L of 2, is that an S, P, D, or F orbital? It is a d orbital. So our sublevel is 3d. So our m sub L is negative 2, negative 1, 0, positive 1, positive 2. So the total number of orbitals we can have with those two particular n and L values is going to be 5. Okay? B gave us an n value of 2 and an L value of 0, okay, which is a what orbital? If you said 2s, you are correct. Okay, the only m sub L value we can have is 0, and so I can only have one orbital that has an n of 2 and an L of 0. All right, the next one we had an n of 5 and an L of 1, okay, which is what? It is 5p. Okay, so I can get -1, 0, +1, and I have 3 orbitals. They can have an n of 5 and an l of 1. Our last one, our n was 4 and our l was 3, okay, which is a 4f. -2, -1, -3 is where I need to start. -3, -2, -1, 0, +1, +2, +3. And so the total number of orbitals I can have with an n of 4 and an l of 3 is 7. Okay, so in future chapters, we will do more with quantum numbers. We'll actually write electron configurations and we'll be able to then go, okay, well, for the 7th electron of a particular element, write a set of quantum numbers for it. All right, so that's upcoming. Right now, we just want to understand how all these quantum numbers work together and what these different sublevels are and what m sub l values we can get and what l values we can get. All right, so quantum numbers, practice them. As usual, practice. Got to do practice problems. You're never going to learn it if you just copy what I write.